Good afternoon. Today's lesson is MCS Geometry, Lesson 76, page 500. Please turn to page 500 and complete the warm-up. The lesson will be on symmetry. Welcome back. Warm-up. Let's see if your answers go. A translation. Is a transformation that shifts or slides every point of a figure or graph the same distance in the same direction. Number 2 is describe the transformation of triangle MPN to triangle M'P' to N'. Let's come over to the figure. Here you can see that M slides over and P slides over. We haven't rotated around any side. We haven't reflected it. Therefore, we have a translation. Funny how they made them both the same. Now, which equation gives a reflection of y equals x squared over the y-axis? I will come up here and point to them. Well, over the y-axis, you'll remember that what we do is we change the x from an x to a negative x. So if we have quantity negative x squared, we still have x squared. Let's look over here. X goes to negative x, so y equals the quantity negative x closed squared, which is still y equals x squared. So we're going to choose A. Now, carefully look at D. It is like y equals x squared, but the x and y are switched, which means that y squared equals x. And that means that y squared equals x is y equals x squared reflected over the line y equals x. We learned this also from lesson 74. Good thing to watch. Symmetry. Symmetry is a term that you're familiar with. It is a property illustrated when the image of a transformation of a figure coincides with the pre-image. There are several different kinds of symmetry. A figure can have line symmetry if the figure can be reflected across a line so that the image coincides with the pre-image. The line that divides the figure into two congruent reflected halves is a line of symmetry. The figure at the right has a vertical line of symmetry. We are now going to identify lines of symmetry. Does this shape have a line of symmetry? If so, draw it. I'm going to freehand sketch in the line of symmetry. So it has one line of symmetry. This polygon, irregular sided, does not have a line of symmetry, so I can't sketch one out. I'm going to go back up to our terms. We have a line of symmetry. We are also going to learn about rotational symmetry, and also an angle of rotation symmetry, and the order of rotational symmetry. That doesn't mean in what order they happen, it means how many times we can do it. So let's go back to C. This little squiggle S has rotational symmetry. If we are to turn it, rotate it a half turn, 180 degrees, it will have an order of 2 because it will have two positions that look like this. Now, imagine this is a regular hexagon and not irregular the way I sketched it. It has two lines of symmetry, one of the first terms, and it also has rotational symmetry, which means I can rotate it. Say I have a flat side, I can rotate it so that the flat side is up again. If this is regular, they would all look the same. So I can turn it to this flat side, 2, 3, 4, 5, 6. So I have an order of 6. Now, if I were to guess, what is the angle of rotational symmetry? That means how far do I rotate it before I get my first symmetrical piece? And that, in this case, is 60 degrees. How do I know that? Well, all rotational symmetries are based out of 360 degrees, meaning once around. If it has a order of 1, it means it does not have rotational symmetry. It can only be in its original position. If we can flip it halfway around, that's 180 degrees. Well, that's 360 divided by 2. Rotational symmetry order of 2. Let's divide by the 2, and we get 180 degrees. In this case, right here, we're still going to take 360 degrees, always take 360 degrees, but we're going to divide it by 6. And that will give us 60 degrees as our angle of rotational symmetry. So we use the order to determine the angle. On page 502, we have example 4. Example 4 is about tiling. That means if you have a business and you're going to put in tiles, you have many different shapes of your tiles. They're all even regular polygons, a triangle, a quadrilateral, a pentagon, hexagon, heptagon, octagon, nonagon, and decagon. Look at the lines of symmetry. The triangle has 3 sides, it has 3 lines. Quadrilateral has 4 sides, 4 lines. Pentagon, 5, 5, on and on. So the question is, how many lines of symmetry does a 15-sided tile have? Solution? Have you guessed it? I'm going to write down 15. Now I'm going to go ahead to the first practice problem. Practice A says the lines of symmetry of a star. It says, does it have any lines of symmetry? Well, I sketched a star, and I drew from this inverted V portion to the point as 1. Then I went from the top point down to the inverted V, and again from the inverted V down to a top point, and from the top point down to an inverted V, and lastly from the inverted V to the top point. Well, that was 5 lines of symmetry that I drew before it starts repeating on the same line. When we consider our rotation, our order, how many times can it be turned? If this is the center, well, I can have a point at the top, and then a second point, a third point, a fourth point, and a fifth point. So we're going to say that it has an order of 5. Well, the angle of rotation of symmetry, which is the second part of B, will be 360 divided by that order. And that just might be 72 degrees, if my math is correct. Well, that takes us through the practice problems on page 502 of A and B. Have fun with C and D, and enjoy this simple concept of symmetry. Let me go back to one more thing. Under symmetry, our faces and bodies appear symmetrical, but a good artist or photographer knows that no one is symmetrical. Yes, that is why police artists' sketches always look a little funny. They are not given details of asymmetry. So when doing a face, we have symmetrical parts, but everything is not perfectly symmetrical. And have fun with your lesson.